The UK is committed to net zero by 2050. To reach that target, we need stronger winds, which we can't do it now because we're based on fixed wind turbines. We need to move to deeper waters. We need stronger winds. When fixed wind turbines cannot work anymore, it means floating offshore wind. Floating offshore wind is the fastest growing segment in renewable energy, projected to be 40% of UK offshore wind capacity by 2035. Floating offshore wind creates a massive complexity. On top of the fixed wind turbines parameters, we need to consider more parameters, including mooring line configuration, anchor types, platform shapes, chain material, and loads of other factors like environmental and physical need to be considered. Each design variation needs advanced physics simulations, which can take more than 24 hours. And just having 100 scenarios can take more than 3 months. And this is just physics, not regulations, not insurance. Engineers cannot explore the full design space, and they rely on conservative assumptions. What do? They do over-design. They add safety margin on top of safety margins. And to just having 10 kilometers longer chain and rope, it means billions and thousands of heavier platforms and millions more cost. This is just one turbine, multiplies it to 100 turbines, global projects. We're talking about billions in inefficiency. The main bottleneck in floating offshore wind is design, and the UK is missing the target by 2050 if they rely on design methods now, what they're doing. That's why I'm here today, to introduce smart offshore design, an AI accelerator on floating offshore wind industry. We use AI surrogate models and optimization algorithms to quickly test many design variations. We explored thousands of parameter design combinations and converge it to a set of optimal design. For example, we can have option 1 costing 7 billion and generating 1.5 gigawatts. And option 2 can cost 70% of the first design and generating 85% of the power. So that actually enables decision makers to have a selected design based on what they need in terms of cost and performance. This idea started from the real point paint industry in 2023. Since then, we built and validated our prototype, focusing on mooring line configuration and optimization. We reduced the design cycle from months to 2 minutes and found more than 50% cost reduction. We engaged with industry leaders like DNV, GDG, and RWE, and I started to working on pilot projects. Smart offshore design can make floating offshore wind industry affordable, fast, and safe. We operate as B2B SaaS platform, providing subscription per project and per user. Our customers are the wind turbine developers and engineering consultancies. Our end users are engineers and project managers. We do is behind the projects as an optimization engine. We integrate to their workflow. I'm Zohreh, CEO and founder of Smart Offshore Design. My background is in electrical engineering and AI. I work directly on floating offshore design challenges, and that's how I experience this industry pain. I'm supported by Josh, my co-founder. He's an experience in AI and optimization as well. Now we're raising 500,000 at pre-seed stage. We're going to be in next 18 months having our first 5 customers and achieve 5 million annual revenue. We will start to extend to EU with countries focusing on floating offshore design. Floating offshore platforms and wind industry cannot escape if they're using current methods by 2050. So if you want net zero, AI design platforms have to move at AI speed. Thank you.
Thank you, Zohreh. So why are you doing this?
That's a good question. I know I should not say that. So this market is a perfect market to make money at the moment. I was in industry. I know how they're struggling with this problem, and I know the knowledge and how to solve it, and I can produce a solution. So what I'm doing it. And most important thing is we need more energy. AI is getting everywhere. So we actually need to go to deeper waters and use floating offshore wind.
Thank you very much.